Hey everyone, welcome to section 2.3. This is where we talk about the power rule and all the exponential rules. There's only one really. This is where we get into the procedural part of how to take a derivative. It's what most people remember about calculus, how to find a derivative. In the past we've talked about what a derivative means and what it looks like, but now we're actually going to find a derivative. These rules are very important. You will do them so much that you will know them in your sleep. Let's start off with the first one. If the derivative of a function is its slope, then for a constant function, a function that looks like this, the slope is 0. So the derivative is 0. The derivative of any number is 0. So if y equals 3, then the derivative is 0. The derivative of any number is 0. Remember that. That should be instantaneous from now on. The derivative of any number is 0. Hey, there's your first derivative rule. You can now find the derivative of every number. It's 0. Take a look at this. If this is the original, this is the derivative, and you can prove that using difference quotient. But I'll just tell you this. It's part of a pattern. It's the power rule. The most common rule in calculus. How to find the derivative of something with a power. You put the power in front, you subtract 1 from the power. So if this is the original, I put the power in front, and I subtract 1 from the power to get the derivative. If x to the 8 is the original, I put the power in front, and I subtract 1 from the power, 8x to the 7th. Makes different quotient useless, because now you can find the derivative in about 2 seconds. Power rule. You will use this rule the most. Okay, let's try a couple of these. What's the derivative? Well, the power here is 1, so I put the 1 in front. Subtract 1 gives me x to the 0. What is x to the 0? What's anything to the 0? 1. The derivative of just a plain variable is 1. So the derivative of x, the derivative of t, the derivative of anything is just 1. Let's take a look at the second one. I hate the way this problem is written because there's not a power on it. It's a square root. But a long time ago, I taught you guys how to turn roots into powers. Remember, it's power tree, power over root. This is x to the 1/2 power. Knowing that makes this problem so much easier if you know how to do fractions. So the derivative, well, let's use red just to be different. G prime equals, take the power, put it in front, 1/2 x to the, subtract 1. What is 1/2 minus 1? It's negative 1/2. That's fine for an answer, but you'll never see the answer written like that on a multiple choice test. That's 1/2. This goes on bottom, and a 1/2 power is a square root. Okay? So what did I do? I rewrote the problem as a power. Always want it as a power. Did the power rule, put it in front, subtract 1, and then clean this up. This is a square root on the bottom. Negative means on bottom. Let's try this last example. 1 over x cubed. Can I rewrite that? Sure can. That's x to the negative 3rd power because it's on bottom. Now let's follow your power rule. Move the power to the front. Subtract 1. Be careful. What's negative 3 minus 1? Negative 4. Again, that's a fine answer, but you won't see that on a multiple choice test. And half of your tests are multiple choice. What will you see? You'll see negative 3 over x to the 4th. Okay? The first answer is fine. That answer and that answer are both fine. They're correct. And if it's short answer, you're done. But know that on a multiple choice test, they won't leave it like that. Power rule. Turn everything into a power that you can. Constant multiplier rule. If there's a number in front, leave it be. Take a look at this example. 7x to the 5th. Leave the 7b. 5x to the 4th. Now 7 times 5 is 35. Just leave the number in front and multiply it by whatever you bring down. So here, let's take a look at this problem, 2 over x. Rewrite it. That's 2x to the negative 1. Let's do the derivative. Y prime equals 2 times. Do the power rule. Negative 1, x to the negative 2. You'll never see the answer written like that. Clean it up. That's negative 2 over x squared. This problem is one of my favorites, this one and the next one, because they show that if you know some algebra, calculus is much, much, much easier. Let's rewrite this problem. This is 4/7 t squared. I always want number, letter, power. So the derivative is, leave the front b, and then do the power rule, 2t to the first. Now clean it up. 8/7 t. Eventually, I'm going to skip this step and just go straight to this step. You don't need to show the middle step. I'm just showing it now because it's new. How about this one? Rewrite it so it's number, letter, power. What's the number? It's 1/2. What's the letter? It's x. What's the power? Power over root negative because it's on bottom. Y prime equals, leave the 1/2 in front of b. Do your power rule. Negative 2/3 x to the, what's negative 2/3 minus 1? Negative 5/3. Clean that up. That's going to cancel out here and here. That'll give you negative 1 over 3. You could do it like this if you want. You could simplify that down if you wanted. You could leave it as 5/3, whatever makes sense. Any of those are fine. Okay? Rewrite the problems. Number, letter, power. And then it makes the problem much easier. So that's the constant multiplier rule. I still consider that the power rule. Sum and difference rules are really easy. A problem like this, that's addition or subtraction, just take the derivative of each one. Take the derivative of each one. What's the derivative of 2? What's the derivative of any number? 0, so I don't worry about it. Treat each term separately. Adding and subtracting are very, very easy. Okay? Derivative of an exponential function. Ever wonder why we always use that special number e, 2.71828, 1828, 4590, 4523, and it keeps going on forever? I told you guys 2 years ago when you took me for calculus that when you get to calculus, e will make sense. Here is why. E has a crazy property. E is its own derivative. The derivative of e to the x is e to the x. It is its own derivative. That means it's a very easy rule to remember. Average versus instantaneous, we've talked about this a lot. The instantaneous rate of change is at a single point, and the average rate of change is the slope between 2 points. So let's take a look at a problem like this. Find the instantaneous rate of change or slope at x equals 4. Instantaneous rate of change. What calculus term does that mean? That means find the derivative. Well, now that I know the shortcut, this is a really easy problem. What is the derivative of this? Let's do one section at a time. What's the derivative of 3x squared? Move this down in front, you get 6. Subtract 1 from 2 and you get 1. Minus. Take the 1 down, you still get 5. That's x to the 0 now, and it's gone. The derivative of any number is 0, so I don't have to worry about it. So that's the derivative. But I don't want the derivative, I want the slope at 4. Well, that's really easy. 6 times 4 minus 5, it's 19. That's instantaneous. That's at one point, and that's derivative. That's a calculus problem. Find the average rate of change from 1 to 5. Average means 2 points. This is not a calculus problem. This is an algebra problem. What are my 2 points? 1 something and 5 something. If you plug in 1, you get 3. Minus 5 plus 1, you get negative 1. If you plug in 5, well, this is ugly. That's 75 minus 25 is 50. You get 51. So this is 51 minus negative 1 over 5 minus 1. That's 52 over 4, which is 13, I think. What's the difference? Instantaneous, derivative, plug in the point. Average, 2 points, find the slope. Most confused topic in this section. That's why there's a mini lesson on it. So today, what did we learn about? The power rule, move the power in front, subtract 1 from the power, and the exponent rule. E to the x is just e to the x. We'll have lots of practice with this, but if you have any questions, come see me, guys. Thanks.